Alright people, so welcome to Jumbo IAS and welcome to UPSC Prelims Phoenix batch. In this batch, we revise the entire syllabus for UPSC Prelims examination, both static as well as current affairs. Now this particular lecture is related to our current affairs lecture series, and as you all know this by now, that currently we are covering science and technology related current affairs. And your today's targets, today's day 5 by the way, for science and technology, and your today's targets were space technology part 2. On day 4, we covered space technology, which was related to missions launched by India. Today, we are going to cover all the other miscellaneous things, scientific concepts related to space technology. Okay, so today is space technology part 2. Clear? So, without further delay, let's revise this entire topic through a set of 20 MCQs. Okay, I'm hoping that you have already revised this topic from the notes provided by us, because those notes were provided to you well in advance. Please finish those notes and then sit for this lecture. All right, I'm hoping you're doing exactly that. All right, then let's begin today's discussion. Let's begin. So, science and technology, day 5, and today's targets were space technology, part 2. So, let's start our discussion with question number 1. With reference to solar flares and coronal mass ejections, consider the following statements. While solar flares are sudden bursts of electromagnetic radiations, CMEs are massive expulsions of plasma and magnetic fields. Both solar flares and CMEs travel at the speed of light, reaching Earth in approximately 8 minutes. Solar flares primarily cause geomagnetic storms, whereas CMEs cause ionospheric disturbances. Okay. Now look, solar flares are released from the photosphere or magnetosphere, okay, of the surface of the sun. So just remember that solar flares are highly charged electromagnetic radiations released from sun's surface. Now, in previous lecture, we discussed the different layers of sun. Now, there is another layer of sun, which is basically sun's atmosphere, and that is corona. Now, corona is made up of plasma. So, solar flares are electromagnetic radiations released by sun's surface, whereas CMEs, well, these are plasma particles, highly charged plasma particles. Okay, highly charged plasma particles released by sun's corona, which is made up of plasma only. So, the material with which corona is made, that is spit out in the entire solar system, whereas solar flares are electromagnetic radiations. Clear? So, this first statement is correct. Now, you all know that all electromagnetic radiations travel with the speed of light. Right? So, solar flares reach Earth in 8 minutes because they are traveling with the speed of light. But these plasma particles are not traveling with the speed of light. They are a little bit slower. They reach Earth in 1 to 3 days. So, this is false. Okay. Now, solar flares generally cause these electromagnetic radiations disturb the thermosphere, one of the uppermost layers of Earth, which contains various charged particles. Now, these electromagnetic radiations disturb that. In this layer of Earth's atmosphere, many satellites are also traveling. So, it disturbs satellites as well. Solar flares cause ionosphere, okay? Like there is troposphere, mesosphere, all these things. So, ionosphere in which satellites travel mostly, or satellites use these ions, not satellites travel, but satellites use these ions. Well, solar flares cause ionospheric disturbances, whereas coronal mass ejections cause geomagnetic storms. Okay, it's the opposite. So, this is also false. The correct answer would come out to be A. Okay, next. Which of the following is our potential impacts of severe solar storm on Earth's infrastructure? Direct triggering of tsunamis and forest fires due to thermal radiation, increased atmospheric drag on low Earth orbit satellites causing altitude loss, induction of currents in power grids leading to transformer failures, scintillation in the ionosphere causing GPS, GNSS errors. Okay, GPS, the satellites that give you location and timing services. Now look, there is no evidence. Remember this, earthquakes cause tsunamis. Okay, solar storms do not cause tsunamis. This is a big no-no. Never believe that solar storms cause earthquakes or tsunamis. But yes, these electromagnetic radiations increase resistance in the orbit of satellites. Okay, so their speed declines, and once their speed declines, their altitude also starts to change. So atmospheric drag on low Earth orbit satellites causing altitude loss, yes, it disturbs satellites. And because solar storms disturb satellites, they are also disturbing satellites which provide you with GPS or global navigation services. So this is also correct. Now remember this term also, because they might ask you a question related to this. Okay, well, the disturbance caused by solar storms in the ionosphere is known as scintillation. Just remember this. Okay, you don't need to get into the depth of this concept. What is scintillation? Just remember, disturbance caused in ionosphere which affects satellites is scintillation. Okay, remember this term, scintillation. Yes, it also affects power grids also, because these are electromagnetic radiations that will affect electricity, currents, magnetic field and all. So the answer to this question would come out to be 2, 3, 4. All right. Okay. Yeah. Next. Consider the following statements regarding solar cycle. A complete Hale cycle lasts approximately 22 years, covering 2 magnetic pole reversals. Solar cycle is driven by sun's differential rotation, where plasma at the poles rotates faster than at equator. Okay. During solar maximum, the sun's thermosphere expands, increasing the risk of satellites burning up prematurely. Now, basically, what is solar cycle? Remember this. Well, this is, let's suppose, sun. This is sun's north pole. This is sun's south pole. Okay, make sense? Now, the thing is that, well, sun flips its magnetic field every 11 years. Okay, sun also has a magnetic field, like earth has a magnetic field. It has a north pole, it has a south pole. Now, every 11 years, the north pole goes south and south pole goes north. This is every 11 years. So 11 years is the duration of one solar cycle. Okay. Now, what happens is that it starts with solar minima. On year 5.5 or year 6, there is solar maxima. At that time, many solar flares are being released. And then when 11th year comes, then there is again solar minima. This is one solar cycle. Simple. Now, this is one solar cycle. So now at the bottom is North Pole and then South Pole. Now, again, after 11 years, North Pole will go back to its north position and South Pole will come back to its south position. Okay. So, North Pole takes 22 years to come back to its original position. Okay. This is one Hale cycle. So, this is correct. Okay. One solar cycle, 11 years, twice that, one Hale cycle. Now, why is there a solar cycle? Why the sun shifts its magnetic field? Because the plasma is rotating faster at equator than poles. The opposite. It is not rotating faster at poles, faster at equator of the sun. So this is false. During solar maximum solar flares are released. Okay. Now, because of this extra heat, thermosphere, the uppermost layer of Earth's atmosphere, it expands. Okay. And there is more heat also. There is a high chance that satellites might burn up quickly. So this is correct. Okay. The answer would come out to be 1 and 3. Okay. Next. With reference to Aditya L1 mission and its payloads, consider the following pairs. VELC observed coronal dimming to track mass ejection during CMEs. Aspects measures dawn time magnetic disturbances. Navik, a solar observing instrument located at L1 point. Okay. So Aditya L1 mission is located at L1 point. Navik is basically our group of 7 satellites which will provide navigation services. So it is not a solar mission, it is a navigation mission. So third statement is definitely false. Now VELC, we have talked about it yesterday when we discussed Aditya. Visible emission line coronagraph. Its whole job is to observe sun's corona, study sun's corona. This VELC is about Aditya L1 mission. And it does study coronal dimming, when the corona is a little dim. And at that point, it spits out a lot of CMEs. So yes. Aspects is another instrument aboard L1 mission which measures magnetic disturbances during morning time of Earth. So this is also correct. The answer would be A. Okay. Geomagnetic disturbances. Question 5. The Kessler syndrome is frequently mentioned in the news in the context of, now what is Kessler syndrome? You see, around the orbits, okay, orbits around the Earth are too much crowded. too much crowded, because the older satellites are also there and the newer satellites are also ejecting their components. This has created the problem of space debris. Now, Kessler syndrome was basically, Kessler syndrome is a hypothetical situation that might occur if this space debris becomes too much. Okay, it's called Kessler syndrome because it was given by Donald Kessler, a person in NASA. Okay, so he said that there might come a time where a small nut bolt in the orbit will hit a particular satellite. That will destroy the satellite. It will destroy into 10 components. Those 10 components would hit other satellites. Let's suppose those 10 components hit 10 other satellites, 100 components would hit 100 other satellites, and surely within a span of days, all satellites would be destroyed. Earth would become dark again. I mean, we are reliant on satellite communication, right? So this is a very dangerous phenomena. Therefore, we need to do something about removing this space debris. Okay, so this is like a doomsday situation predicted by a NASA scientist called Donald Kessler. Hence, it is called Kessler syndrome. Cascade of series of collisions in orbit making space activities impossible. Okay, next. Regarding India's initiative for space situational awareness, consider the following statements. Now, already there are so many satellites that are in danger of being hit by this space debris. Therefore, space situational awareness is very important. ISRO needs to know where this debris is so that our satellites will basically orbit clear of these debris. Okay, so that our satellites don't hit this debris. So we need to be aware of where this debris lies. Okay, this is known as space situational awareness. Now, what has ISRO done so far for this? Project Netra includes high-end phased array radar located in Assam. IS-4OM is a system dedicated to carry out collision avoidance maneuvers. Debris-free space mission 2030 aims to move all dead satellites to graveyard orbit below 500 kilometers. Okay. Now, yes, Project Netra has a radar which is located in Assam, which locates all this debris and informs the satellites. Okay. IS-4OM, okay, space satellite debris removal mission, is a system dedicated for collision avoidance maneuvers. That if a satellite is traveling towards the debris, it avoids it. Okay. Yes. Debris-free space mission 2030 aims to move all dead satellites to graveyard orbit. Now, what is a graveyard orbit? All dead satellites should be moved to graveyard orbit is mentioned in debris-free space mission, international mission. But where is graveyard orbit? It is 300 kilometers above geostationary orbit. Geostationary orbit is 36,000 kilometers above Earth. So 300 kilometers even above 36,000. So 36,300 kilometers. Dump all the dead satellites over there. Not 500 kilometer above Earth. Okay, so graveyard orbit is not this orbit, it's this orbit. So that is why it is false. Okay, so the answer would come out to be B. Right? Next. We have discussed this. With reference to SpaceX mission experiment updated in 2026, it's primarily a precursor technology for, well, Bharatiya Antariksh Station and debris removal. Because SpaceX mission is basically a docking mission. So if you can dock satellites or spacecrafts, you can send a spacecraft to remove debris and dock it with some other spacecraft and take it back to Earth, right? So this docking mission is crucial for Bharatiya Antariksh Station in 2035. We have discussed this. This is space vision. And active debris removal also. Active debris, the debris that is there in the orbit. So the answer is B. Next.